I need to go over the assignment that we did for yesterday. I think I didn't make it clear enough, or my directions weren't very good, or I didn't teach it well enough. No matter what the case, let's just go over it again. And then I stopped correcting those from yesterday because a lot of people were making the same mistakes. And again, don't worry, that's on me. You can go back and you can fix those, and then you can get the full credit for that, including the extra credit point if you had done that. So I'm going to give a few examples this way, and then I'll show you how to do it on the assignment. I'll use the marble situation. So let's say that there are marbles, and they're the different colors, and you can find out what the probabilities of each marble is. Since there's 10 of them, to get the probability of getting a black is 2 out of 10. The probability of getting a red is 3 out of 10. The probability of getting a blue is 1 out of 10. The probability of getting a green is 4 out of 10. So that's kind of the first ones. That's really not that bad of finding out those things. But then once you get into more than one event, that's where it gets a little tricky. Example would be, now if we can replace them, they're not dependent events, they're independent events. So I want to find out the probability of getting a black one, and then the probability of getting green one. So not dependent, you can put them back. So the probability of getting a black one is 2 out of 10, and the probability of getting a green one is 4 out of 10. So my probability of getting a blue one and a green one would be 8 out of 100. Because you just do top times top, bottom times bottom. So I'm just picking those and then replacing them. This is where we had the trouble. It's when you don't replace them. So the chances, if you're not replacing, if I want to get the probability of getting a red one, so probability of red, and then a probability of getting a blue one, but you're not replacing it. So if the probability of getting a red one, I take it out, and then the probability of next getting a blue one, it changes. So the probability of getting a red one is 3 out of 10. But now my probability of getting a blue one isn't 1 out of 10 anymore. It's 1 out of 9. Because there's only 9 after I've taken one away. So that's 3 out of 90. And then I can just simplify that to 1 out of 30. That's where we had some trouble with the assignment. Another example would be, what's the probability of getting a green and then a red? So the probability then of getting the green first and then a red would be, a green one would be 4 out of 10 chances. And then after I've taken that green out, what's left is I have 3 chances to get a red out of the 9. So I get 12 out of 90. And then you can simplify that. It's 4 out of 30 and 2/15. The numbers get kind of big in the assignment. That's why it's kind of annoying, but it's really not that terribly bad. Last example is, what's the probability of getting black and then another black? So the probability of a black and then another black is, it's 2 out of 10. And then, since you've taken that one out, it's 1 out of 10 more. So again, 3 out of 100. In the assignment, and you can make this correction or changes, there's 5 students in it who have blue eyes. There's 7 who have brown eyes. There's 4 with hazel eyes, 4 with green eyes. And if you add all of those up, you get 20. So we're talking about 20 students overall. And then the chances of getting a green and then a brown. So you'd say the green chances are 4 out of 20. And now you're not putting it back, because what's the other student? The chances of a student with brown eyes, then it's 7 out of 19. And you just multiply those to get it. And then it comes out after you simplify like 7 out of 95. Number 8, getting 2 blues. Well, the first blue is a 5 out of 20 chance. We've taken that blue out. Now it's a 4 out of 19 chance. You simplify those, get it all worked out, multiply, simplify, get 1/19. And then hazel, then blue. Chances of hazel eyes are 4. And then a blue, it's 5 out of 19. See, I'm messing it up myself. Then you multiply that out, simplify, it gets like 1/19. Okay, hopefully that makes sense. Brown and blue, same idea. Questions 21, 22, 23, and 24, those are all independent events, so you don't have to worry. It's just find out one of them and multiply it by the other. It's not a big deal. Just be careful with just make sure you count the right numbers. Now these ones, 25 through 28, these are just the dependent ones. So there are 3 red, 4 black, 2 green, and 2 yellow. Just completely like the problem that I had just done with the marbles on this one. And since there's 11, which isn't a great number to use, I don't know why they did that. Chances of a red are 3 out of 11, but then the next chance for red is 2 out of 10, and we get 6 out of 110. 3/55. On number 26, it's finding out the black and a yellow. So the chances of a black one are 4 out of 11. And the chances of a yellow one then are 2, but there's only 10 left because we haven't replaced it. It's 8 out of 110. A red and a black, same concept. 3 out of 11 for a red. 4 of them, but there's one of the reds gone. It's 12 out of 110. And then that, you can simplify that down. It's 6 out of 55. And a green and a green, same concept. 2 out of 11 for a green. Now there's 1 green left, so it's 2 out of 110. That's 1 out of 55. Change your answers, and change those answers. I'll give you the points on that one.